Okay, so I'd like you to get out the packet that I gave last week. Starts with function notation, evaluating functions. We left off here at these piecewise function problems that we did the week before the snow. So I'd like to talk about key features of a graph, and today we're going to start talking about intervals. All right, so intervals is a fancy word for sections. Okay, so let's pretend that this is a roller coaster that's on the side of the Grand Canyon. So this line here, the x-axis, is the land, and where the roller coaster dips down is below the land, okay? There are lots of ways that you can describe this roller coaster. You could say, oh, it goes down, then it goes up, then it goes down, then it goes up, then it goes down again. You could also say, hey, from here on, it's actually below the land. So here you're looking down at the side of the canyon. Here you're in the canyon looking up. Now, in real life, we would have terms that describe that, okay? Here, we're going to use very specific words like decreasing, increasing would be like it's going down, it's going up. When it's below the line, this would be negative because it's in here with the negative numbers. Up here would be positive. But intervals are basically just sections of the graph, okay? There are 6 interval types, and they all tell us something different. So domain is all the possible x values. So if we were looking here, it looks like we kind of start at 0 and we went to maybe 5.5 seconds. So obviously if this was a roller coaster, this would be time, x. So it would be from 0 seconds to 5.5 seconds would be our domain. Now, I would like you to notice, I did not say, hey, from up here at 0:35 to 5.5, -15. When we're dealing with intervals, you just say the x where it begins and the x where it ends, okay? So from here, I don't say this ordered pair to this ordered pair. I say, oh, it's from 0 to 5.5. Increasing is when the slope is positive. So it's going up as you move from left to right. So if I were to look again at my example, I would have 1 increasing between 1 and 2. So if I looked over here, between 1 and 2 seconds, between 4 and 5 seconds, and those would be your 2 intervals where it was increasing. Now, I could also have decreasing, which is where the slope is negative. And so it is going down. And if I look at my if I look at my example here, I've got 1 that's going down between 0 and 1. I've got 1 between 2 and 4. And then I get 1 from 5 on. We'll say 5 to 5.5. We'll talk about how to treat that in a minute. Okay? All right. Positive is above the x-axis. And so negative would be below the x-axis. So if I'm looking at this, everything from 0 to 3 would be positive, and everything from 3 to 5.5 would be negative. Now I am generalizing. I realize that there's a couple places here where it's not actually negative, so it's 0 at these points, but in general, if it's above, that is your positive. It's below, it is negative. Now, I would like you to remember here, up until this point, we are only using the x value. The x value from here to there, from 0 to 1, from 1 to 2. We are not writing ordered pairs when we are writing intervals. There's two ways to write that, but in general, we are not writing ordered pairs. So if I look at this, interval notation would be, let's take that 0 to 3. If I'm using interval notation, it would be from 0 to 3. Now, I just randomly chose one. The parentheses means that it is not equal to. So that would be like 0 is not equal to the x, and it is equal at the 3. So the parentheses means less than, but not equal to. The bracket means less than or equal to. You always go smallest to largest. Again, I am not caring which one you use. You have to know both of them because I will use them equally, okay? Now, here's a weird thing about a graph, because not all graphs are equal. I literally pulled this one off the internet. I just went to Google Images. You have to kind of assume that if a line does not end where you can see it in the middle, you see how this kind of ends at the same place at the bottom? You're going to assume that arrows are implied. When a line goes off the edge of a graph. Okay. So if you have an arrow, it is never equal to at the arrow. You will never have an equal to at the arrow. So if I'm looking, for example, if this section right here from 5, and we're assuming that this goes down forever, which in our example couldn't happen, but it would be from 5, starting at 5, where it was true at 5, and then it went down forever to 5.5, and you never, ever, ever have a bracket where there's an arrow. Okay, so I skipped something on purpose. Range is the weird section because most of the time the section is from x value to x value, where it begins to where it ends. Range is the exception. Range is the y value to the y value. Okay? So if I'm looking at that, it's because range is about how tall something is, or about how high, or the output, not the input. So if I'm looking at the x values, it was time. Where am I between 0 and 1? I'm going down between 0 and 1. I am going back up between 1 and 2. I don't say the entire ordered pair. But if I am looking at the range, I'm saying, what is my highest y value, in this case 35? What is my lowest value for y, which is negative 15? So this, we'll assume, we'll go back and just put a dot here so that we can use that instead of infinity. We'll do some infinity ones here in a minute. But if I'm saying negative 15 is the smallest number that I have, then I would start with negative 15 as a range, because range is y, so it's the only time I use the y's. And then I would go up to 35. And again, if I'm using the brackets, that would mean negative 15 is less than or equal to y, which is less than or equal to 35, because range is the y value. Okay? Now, let's turn the page. We are not going to do these today. We're not going to do these tomorrow. Just trying to get you to have the idea of, because we're already so far behind. Okay, so let's talk about what makes sense in a real life situation versus math, just math. Okay, so let's say I am looking at domain. All right. So the x value where this graph begins would be 1990. The x value where this domain ends would be 1998. That is almost illegible. And they were solid dots, so we're going to have brackets. Okay? The intervals of increase, what's going up most of the time? So we have two intervals, because there's a gap there in the middle between 1990 and 1991, and between 1992 to 1998. Our decrease is where the slope is negative. I just have between 1991 to 1992. Okay? All of this is above the x-axis, so the entire thing is positive. So that would be just like our domain, because the entire thing, 1990 through 1998. The only one that's different is our range, which would use the y value. So if I'm looking here, my smallest y value was 270. And we've got to estimate here, it looks like they're going up by 270, 290, 310, 330. So we don't quite get to 350, so let's say 345. Okay? As opposed to math. I think everybody, when it's a real world example, you get why you're only using the years, okay? But when it's math, you're just so used to using ordered pairs. Like, I know this is -1, -2. I know this is 1, 2, 3, 4, 5, 6, 7, 8. And this is -3, 0. Now this is infinity. It is negative infinity, negative infinity. It is, everything in this quadrant is negative, negative, and it's going forever in that quadrant, okay? So if I'm looking at domain, I'm looking at all the x values. Well, my rightmost x value is negative infinity, and my leftmost is negative infinity, rightmost is positive 1. Notice I didn't use the 8. The 8 is not an x value. The only time we use the y values is for range. So if I look at increasing, now this is where it gets confusing. That arrow looks like it's going down, but the slope here is positive. If I move from the left to the right, I'm going up in this section. So it is increasing from negative infinity to -3. and it is increasing from -1 to +1. From here to here. My decreasing would be that part in the middle from -3 to -1. Why am I using brackets? Brackets is for either a straight line or a dot, solid dot. Parentheses is either for an arrow or an open dot. That is way oversimplification and is not quite true. But with I'm not there to give you the little nuances of it, we're going to stick with that for now, and then I will correct my mistakes, on purpose mistakes, but I will correct the exceptions to this rule on Monday or Tuesday, because we don't have school on Monday either. Okay, now, positive would be above the x-axis. So positive would be, it starts being above at 0. It's not actually above at 0, which is one of those exceptions, and it goes to 1. It is negative from -infinity. I'm oversimplifying here to 0. Those of you who have parents who understand this actually should be two separate sections, because right here it's not negative or positive, it's 0. So technically you should say from -infinity to -3 and from -1 to 0. But we're not going to be that picky just yet, okay? Then the only one that would use the y is the range, which would be from y is -infinity to 8. Okay, so I am hopeful that is enough for you to try. This. And then on Monday, no, it's not. I want you to go on Delta Math and do some practice on this with Delta Math. I will have some problems that deal with domain and range and increase, decrease. So do your best. We're just hanging in there. I'm sorry I wasn't able to teach this before because of the snow days. So do your best and it'll all be good. Have a good one.